And the model that we were gonna work with, we started out with some mountains, and we said that mountains has many hikes. So in order for a hike to exist, in a sense, it has to belong to some location. Technically, this could be like a mountain, a lake, anywhere, but that the mountain is the model that we have. And we also defined the relationship that hike belongs to. And the keywords that I want you to pay attention to is the has, many, and belongs to. Those are gonna be words that you'll be hearing over and over again. Another way that you might have noticed this is introduced is like the one-to-many. So a hike, like mountain is the many, the hike is the one. So one mountain to many hikes. So if you're also looking at that vocabulary, that's what that means. Sweet. And before we get started, are there any questions that people want to add to like our slabats on top of the one-to-many relationship? Sweet, cool.
Real quick, you could also have, say, one mountain has many hikes, but then the mountain, there could be many mountains in a national forest. So you have one national forest that has many mountains.
Yeah.
That one mountain, so it could then kind of fork off multiple times.
Yep. If you want to kind of like add that new model, like the forest model that you're talking about, then you would create a separate class called forest. And that forest can be like, I guess it'll be like the area of the forest or like dimensions of the forest, what's the city it's located in, country. And then you can definitely say a mountain or a forest has many mountains. And then you can like fill in all the mountains. And the cool part there is you can also, because hikes already has a relationship with mountain, you also have like forest has many mountains and mountains has many hikes. So mountain belongs to a forest and a hike belongs to a mountain. So that's where that's the coolest part about like domain design is you can take any real object or anything out there in the world and convert it into Ruby objects now.
But you can't say a hike belongs to a national forest, right? Because that's outside of the scope.
For now, yes. There is technically a way you can get to the forest. Because the mountain has like mountain is kind of the relationship in a sense between the hike and the forest. So there is a way you can. But for now, yeah, it'll be kind of hikes in its own little thing, own little model.
Cool. Thank you.
Yeah. All right, sweet. And we'll get another practice with like creating a whole separate domain and whole separate class towards the end of our lesson today. So if there are no further questions, let's progress. Let me see where we got. So what we have so far is we're in our, keep on clicking on that hikes. We're in our sample.rb. And we have our mountain class that we've been working on, and we have our hike class. And the most important distinction that we made through the end of the class is because hike belongs to a mountain, when we represent this relationship, hike is actually storing the mountain object. Until that moment, you say, I'm passing in a mountain instance to the specific model or to the specific height instance, there's no relationship at all in code for that project. I already wrote this in because I was prepping before, but if we are saying in our case, a hike belongs to a mountain, so we're storing a mountain object, we can also say it the other way. So now it's like, okay, a mountain has many hikes, but how am I going to represent that relationship? And we already have an idea that, okay, we're storing some instances, but in this case, because a mountain can have many hikes, it needs to be able to store many hikes. So we can start out by kind of like just having a hikes array in the mountain class. And the most important part here is this hikes array is not just an array of strings, it's not just an array of integers, it's an array of all of the hike instances that is in that mountain. So now we have a way to take a look at our code and say, what are all the hikes that belong to me? Or a mountain can say, what are all of my hikes that exist right now? Any questions on this? All right.
Well, each class needs to have a reference to the other. Yep. You could have, the hikes could have a reference to the mountain and they'll know they're a mountain, but if the mountains don't, the mountain class doesn't have a reference to the hike, it won't know.
Yep, exactly. That's the important distinction to make. We now have two classes referencing each other. I love that word reference because that's basically what's happening here. We're saying the hike is referencing the mountain instance it's in. The mountain is referencing all of the hikes that it has. So when we're talking about hikes, and somewhere in here I have this, there's going to be an array or of called hikes. What kind of variable should it be? Should it be a class variable or an instance variable? Any guesses?
Yeah, ask that question again.
Yeah,
You said,
so
yeah.
our hikes variable, we said, all right, this mountain needs to keep track of all of the hikes that it has inside of it. But when I'm adding this hikes variable in, should I add it as an instance variable or a class variable? And
Class.
Class variable. And what's the reason for making it a class variable?
Because
So
it
it's
wouldn't work
accessible.
outside of that if it was an instance variable.
Wouldn't look
Is it-
outside of that. What do you mean by that?
You wouldn't be able to call it.
From the mountain. So I'll say like hikes equals array, similar to the add it all.
Hmm.
So what happens if I have this add it all at hikes, and let's say that I initialize it. Well, we initialized it here. Cool, class variable. What happens if, in our case right here, Mount Si has 5 different hikes, Pilchuck has 5 different hikes, and Tiger Mountain has 5 different hikes? How would you be able to distinguish between which hike belongs to which mountain? Or what you would add? What would you add in here if we did make it a class variable?
Hash
Wait.
array.
Yep.
Array of hashes.
An array of hashes. So something like maybe like Mount Si. Would this be like the object or the string? Which one would you want? Maybe like Mount Si. And then it'll be like the hike object that belongs to that as a value, like a hash of an array. Hash of an array. Cool. So we'll say Mount Si has an array of all of these different hikes. Hike 1. Oh. Hike 2. We'll create these hikes in a bit. Hike 3.
Why
then-
are the hikes within the carrots?
Typically, I use carrots to indicate that it's going to be an object. So that's
Okay.
something that I do on my end. And the reasoning for that is if we run this program, we'll say ruby sample.rb. Yeah, it's not going to like this because I'm creating fake hikes, not using like syntax. So we can say ruby sample.rb. What did we do at the end? Oh, right. Let me comment this out too. And sorry, trying to do. So we are, oh yeah, and let's say I call like Si. The reason that I put the angle brackets is just because of this. Anytime you see this like angle bracket hashtag sign, it means that's the whole object and everything within that object is nested inside of that. So that's the reason for the caret or the angle bracket tags here. Sweet. So we have some kind of idea of how we want to store this in a class variable. We're saying Mount Si, it's going to be an array of hashes, and this will be for like Tiger Mountain, etc. What would be the case if we made this an instance variable? What would that look like? So
It would
this is
just be thrown in the instance or initialize and
in the initialize down here.
yeah.
So we'll say at hikes, and we can say this is an array. And what would be the advantage of making it an instance variable rather versus like a class variable? Because you have ways.
It seems way easier to work with.
That's the main thing here. You can make it a class variable. Because the class has access to everything, it needs to also be able to keep track of those instances. So you need to add that extra step to look at, all right, I have an array of all of the hikes that have ever been created. And you need to add in that extra step of now which one belongs to Mount Si and Tiger Mountain. If we make it an instance variable, this automatically is only going to belong to Mount Si or Tiger Mountain or Pilchuck. So whenever you're thinking about whether it should be a class variable or instance variable, if it just belongs to that specific mountain in this case, it can be an instance variable. And that way you're protected. So Mount Pilchuck doesn't know anything about mountain size, heights. They're like, oh, they only know about themselves. Yeah. Any questions on this?
Why can't you do the same thing? Add at hikes there in the initialization. Like similarly, you have the add at all shovel self.
Yeah, I can say add at hikes shovel self. That'll still work. You'll also have to keep track of the instance. That's the only thing. So you can shovel in self, or wait, you can't shovel in self, but you can shovel in a hike. Like we'll create a separate method for it. So it won't happen in initialize, but you can have a separate method that takes in a hike and it adds it to our class variable. You just need to add that extra step of adding that key in there or adding some kind of reference to know what mountain it actually belongs to. So in this case, the only reason that we're making it an instance variable is because hikes is something that's particular to a mountain instance. You're never going to have a case where, well, there might be exceptions, but you're never going to have a case where there's a hike in Tiger Mountain that also is going to be in Mount Si because they're two separate locations. That's why they're going to be instance variables.
I have a question.
Yeah.
For class variables, is it like do you typically only use one class that at all, and that will be your like just as a best practice, and then you don't have multiple, or is it common to have multiple class variables?
I would say it will be common to have multiple class variables once you make your project bigger. And for the scope of our Mod 1 projects, we'll probably just have this like add at all.
Okay.
But if you're ever building a method that you know is going to have, it needs to reference like all the mountains or all of those instances, you can track it in a class variable. It's just for our design purpose right now, add at all takes care of that because it's already keeping track of everything and we can reference it anywhere we want. It's a good question. All right, so we'll keep hikes as an instance variable since this is going to be particular to that specific mountain. And now let's kind of work on this deliverable. So right now we've just been like saying hike.new and passing in like a hike and assigning it to our mountain or passing in the mountain instance like so. And we can streamline that a little bit because if we have a method in our mountain that already is going to handle adding a like, then we won't have to worry about inserting that in our hikes array or letting hike take that responsibility. And so we're going to write a method next. And you might have already written part of this yesterday when you were working on your kind of like project to build these methods out. So we're going to add a method add hike. It's telling us it takes in a name. So it's going to take in a name. And it's going to create a new hike. So I'm going to copy and paste this. Create a new hike and add it to the mountains hike collection. All right, and whenever you're looking at a deliverable, the first question you should ask yourself is, what are the variables that are being passed to me? And in order to complete this, what classes do I have to talk to? What variables do I have to talk to? And when I mean talk to, I just mean which classes do I need to reference in order to complete this deliverable. So if I need to create a new hike, well, I guess first step, what kind of name is going to be passed into this method? What is this name referencing?
Real name.
The hike name.
Yeah, it's gonna be hike name. Oops, I don't know where I typed. So this name is specifically going to be the hike name. And this will also help us decide what we're doing in the next deliverable. What is create a new hike? Who do I have to reference or talk to in order to create a new hike?
To the class hike.
The class hike.
Add new.
Yeah. Here's a couple replies. Awesome. So I'm gonna create a new class. And what we should be taking a look at is what does hike take in as a class in itself. And after we create that method, I'll organize this a little bit so we're not like scrolling up and down, and we're practicing like good practices. But for now, we know that hike takes in a name, which we're getting as a parameter from our add hike method. And we are also passing in, or we need to pass in a mountain object. And this is the whole instance itself. So let me put a binding.pry here. And I will sample.rb. And let me call add hike. I think I have, can finally use this hikes that we undefined method mountain dot, ooh, okay. I don't know why I made this a class method. Let me make this an instance method. I'll say sci. Let's add this to sci. All right. So I'm going to clear the screen out and say add hike again. Oops, I'm already in the thing. Where am I? All right. So I'm in my pry. I have add hike, and we have a hike name that came in. So let me type in name. So that's the name that we're passing in. This was my argument. Bear peek out and back. And this is my instance or the mountain that I'm trying to add it to. And what's the keyword that I can use to get access to the mountain that I'm in?
At mountain. Is that?
Mountain. So I'm in the mountain class already.
Oh wait, I'm
Did
sorry.
you do self?
Yeah. So if I'm in the hike class, then I have access to the at mountain instance. Right now I'm in the mountain class. And because I said sci.addHike, self is going to give me access to that whole thing. So anytime you see we're creating a new hike or creating a new instance and we need to pass in that object or pass in that instance, you're going to use self. So this is a perfect opportunity to use self. And this way, you don't even have to call like the name, the longitude, latitude. You can just pass it self. That's it. So we're going to say, clear this out. We're going to say hike.new. And order does matter. I mess this up all the time. Name first, then mountain. So we're going to say name first and then mountain. I will pause here. Any questions on this? Thoughts? Sweet. And then what would adding this to the mountains collection look like?
It'd be
The array and then shovel on the name.
Yep. And that's
hikes, shovel.
Add
Yeah.
hikes.
And that's the cool part about having this an instance variable, because I automatically have access to all of my hikes. So I can just shovel it inside of there. So I can say add hikes, shovel, and then we need to shovel the hike instance. So probably can make this a variable and store it in hikes. You could probably just like shovel it in there, but I like separating my steps a little bit to help debugging in the future. And I know some of you had questions yesterday, like when can you make something a local variable versus an instance variable? This is a great example. I'm creating this hike, but I don't need to reference it outside of my add hike method. So you can make it a local variable, and then it's okay if you kind of lose access to this.
So by doing this, you're adding on the name of the hike, and then you're also passing on all of the mountain data by using self, right?
Yep.
So then the array would be the name, or the array would be the name, and then also all of the array of the data of the mountain.
Yes.
Okay.
That is true. And let's add, I think the next one, I'll not focus on the group activity for now. So this next one, we had an add hike. We added our hikes array. This says that there needs to be a method that returns the hikes to the user. The cool part is since it's an instance variable, we can just say at hikes. So now I have a way to just say sci.hikes and get access to all of them, or my one. So do. Oh wait, I have to run it. Let me reorganize this a little bit, and then we'll come back. I will copy paste all the test cases that I have in that other file. All right, so you might have noticed just from like me running through these examples, I'm scrolling up and down a lot, and it's very easy to kind of lose track of what class I'm looking at, where am I in my code. So we're gonna kind of like talk about reorganizing our file structure so that we're separating our concerns between the classes that we're using and the test cases that we're writing. And in this case, the test cases are just the .new that we're doing here. So typically by convention, we already have a couple classes inside of here. In Ruby, when you're separating your classes out into files, each class is gonna have its own file. So we're gonna create a separate file for mountain called mountain.rb, called hike.rb. You'll see some cases where this is like uppercase. By convention, I keep all of my Ruby files lowercase. And I'm gonna put it all in a folder called models. Similar, exactly the same as lib that the labs do. I'm gonna say hike.rb and mountain.rb. All right. So let me go into sample. I'm gonna just cut all of this out.
Why'd you call the folder models, and why not have it in like library or code?
Yeah, you'll notice like it's the same, or the labs use lib for library. You'll notice like some labs use app for like your whole application. By convention, you are going to eventually get to a point where you're gonna have a separate folder called models, and that'll be all of your Ruby files. And then we'll be adding in some like databases, so that'll go in your database folder. So this is to kind of get you set up for that, more like get you comfortable with the syntax of what your future files are gonna look like. Yeah, so you'll notice like different labs and different projects will use different convention. So get comfortable seeing all different options that are available to you. I use models. The main part is your classes are in a separate file. So you should never have two classes that are in the same thing. Yeah, that's a good question. I don't think I copied everything. What did I do? The struggles of, oh, there's a lot of code here.
Split screen makes everything really small.
Yes, I was thinking of buying new. I also pasted that into the wrong class. I was thinking of buying like one of those curved monitors because I was coding yesterday and I was like, this is a struggle. I need more space.
Do it. You won't.
I need like options. I'm really bad at buying stuff. I think about it for like 6 months and I'm like, I'll take the plunge one day.
How big of a monitor are you looking for? Like a 34-inch?
I have no idea. I wish I could. I don't know. I'll think about it. I think just like anything that's larger than what I have right now, which is like a basic monitor. Which, I don't even know what the size of this is. All right, so we took our classes out, and now hike and mountain are in their separate class. What's something that you might notice will come up as a problem at this point?
Binding.pry won't work in some.
So let's see. Yeah. When you hit try to run binding.pry, we get our infamous error again, uninitialized constant mountain. And it's not that it's uninitialized, it's that it now lives in a separate location, so it's not going to be able to recognize it. And that's another thing I want to point out with binding.pry. If you hit any errors before this, it will hit the error first before it hits your pry. So this is another great indication or debugging process for you. If you have a pry at the end of your file and everything runs through and you make it to that pry in a sense, that means all of the code before it works and you were able to run it. So that's another check for you to make sure that you're getting access to everything. So our case right now, we aren't including the mountain or hike at the moment. Quick fix for that is the require relative. Require you use for gems that you're using inside of your project folder. So all of the gems that are coming from our gem file. Require relative is all of our Ruby folders. And this relative is super important because this is relative to the file that you're currently in. So I'm in sample.rb. My mountain and hike is in the models folder. So I need to go into the models folder before I reference hike and mountain. So you really have to pay attention to where your current file is for that require relative and where your goal file is or where the source code for those specific classes are. So I have to say models and then hike. And I'll do the same for mountain. In Ruby, the RB is optional. So if you say like require relative assumes it's a Ruby file, so you won't have to specify the extension.
So what would be the difference of saying like require all?
Yeah, so require all is used for folders. We'll eventually, why did I put S here? We'll eventually start using require all. Require all is another gem that we can use that'll require the whole folder itself. So we'll get to a point where we'll just require like app, or we will require models, and it'll just give us access to everything. Yeah.
Okay,
so
thank you.
same thing.
And if the files were in the same directory, we didn't need to put the models before, or the path?
If you're using require relative, yes. If you're using require all, and I would need to like add the gem to my gem file. So that would be like require all models, and that's all you would need to do.
Okay.
Yeah. So if you're using require relative, it's looking for that specific Ruby file. So you would need to put models before it, since they're both in models. Sweet. Now I have this. Oh wait, no. Yeah. Let me run this again. All right. So we made it to the end, which is good because it was able to find mountain and it was able to find hike. And what I typically like to do in the beginning, as soon as I've created some instances, is test my add@all and make sure that I have access to the data that I created. So in my hike, I have this add@all variable. And I have access to, I have the getter set for it, and same thing for mountain. I have the add@all for all my mountains, and I have the, I think I have the getter set for it right here. So I can say mountain.all. Got my mountains, cool. I'm gonna clear this out. Say house.all, house.all, what? Hike.all, and I got all of my hikes. And the cool part is I now have access to my mountain, which is amazing. Cool. Now, it'll make it a little bit easier for us to like add code to this because we're not scrolling up and down anymore, which is awesome. We've separated our concerns a little bit. I have like sample hikes that I looked up, the random names that I found for now, and I'm gonna randomly assign it to a hike. So for some reason, I think I was like prepping late at night. I don't know why I made this a class method, but I am going to change this to mountain.all. So I'm accessing all of the mountains that have ever been created. And a method that I like to use for arrays when I'm trying to choose random things is .sample. So I'm going to say .sample. .sample return a random instance from an array. So I'm sampling some random mountains from mountain.all, and I'm calling the add hike on that specific mountain and creating a new hike. So we can have some data to work with. So if we take a look at our mountain class, this is going to, let me take out my binding up right. This is going to take in that name. It's going to create a new instance of hike. It's going to add that hike to that specific mountain's hikes array. Sweet. Any questions on that?
So the mountain will be picked random because you add the all random, or was it?
Yep. The mountain
sample. Okay.
The .sample allows me to grab a random instance from my add@all, mountain.all, and add that hike to it. So that way it's a little bit more randomized and not just like us adding the same hike to like 5 different, or the same 5 hikes to the same mountain.
I'm sorry, but I'm a bit lost right now. What's happening right now?
Yeah, so what we've done so far is we've completed, thank you for asking. What we've done so far is we kind of moved our hike class and our mountain class into separate files so that we can read it a little bit easier. And what we've done is we finished up our hike class, and in our mountain class, we said, now I want a way to keep track of all of the hikes that belong to me. Because sure, we got some hike objects, but which ones are at my specific mountain? So we added this hikes array. And whenever you're representing a relationship between two different objects, we need to pass in that whole object instance. So rather than just saying the hike name itself, we're gonna pass in that hike object. And in order to do that, we created a method called add hike, and that will add the specific hike object to the hikes array, and it will also create a new hike. So we're saying this is a new hike that I'm adding to this mountain. I'm going to create the hike, and I'm going to store it in my hikes array. Yeah. And is there any further questions that you want to build off of that?
Have we built out the seed data for our hikes yet? Or I'm confused by that in the sample.
Yeah, so right now, we are creating the hikes as we add them to the mountain. Because I'm saying mountain.sample.add hike, and this add hike creates the hike.
Is this the only way to do that? That hikes, the hike information?
You can also do this. You can say hike.new, pass in poo point. You would just need to pass in the mountain instance. So that's the other way you would do it. The exact same thing is happening here, except in our case, a hike can't be created unless there's a mountain associated with it. So we're streamlining the process. We're saying I have one location that I can create a hike from, which is through this add hike method.
With using the dot sample, is there any guarantee that it's going to go to the right mountain?
There is no guarantee. This is completely random.
So if you want to be more specific, do the hike.new, and then you can assign what you want it to be assigned to.
Yep, exactly. Okay. I just chose like random hike names, which is why this is completely random. And I'm just using like the 3 mountains that we've created so far.
Why is there a binding?
Go ahead.
Why is it a binding.pry in a sample?
Yeah, so the binding.pry is so that I can call methods and see what these variables are. So the binding.pry is more for us to kind of see and test the code after we created all of our instances.
Okay.
So on line 16, you're adding the hike to the Tiger Mountain. Couldn't you also then on, like, say at line 17 or any of those other ones, put like if you know the mountain tiger dot add hike?
You can.
Okay.
Yep. This is so that if we add like a couple more mountains, then I don't have to go in here and manually change the mountain names. This is for once we start adding more and more test data, we can just randomly sample it.
And this is probably outside the scope of what we're doing now, but we're kind of seeding, I think, a conversation for later. This seems like it's a really awkward way to get data. So,
the strings?
Writing it all out like this.
The mountain.all.sample?
If you had 1,000 hikes, you have to write 1,000 lines of code.
Yes, that is true. Yep. We'll introduce like databases later, so there'll be more efficient way to store this. Okay. For now, we're kind of just working with small amounts of data. So we
gotcha. And learning more so how they work. Okay.
Yep. Yeah, that is true. This will be better in the future. All right. Any other final questions? I know the syntax can be a little weird to see.
Let's assume hike names don't repeat.
In this case, the hike names won't repeat because it's only going to run this line once.
Yeah.
The mountains will repeat, and then the mountains will have multiple hikes that we added. Right?
Exactly. So the mountain that's going to repeat between the 3 of them, randomly chosen. So it kind of diversifies a little bit. So it's not just one mountain having like 5, and then we add like 1 for one mountain. Yeah.
I know we went over this
Um,
the other. Go ahead, Nate.
go ahead.
I know we went over this yesterday briefly, but do you mind showing me later how to do the gem file again?
Yeah. Let me
I second that.
show you now. So we're only using pry in here, so it's fine. Just for the sake of reviewing, I'm gonna delete these both. So what we've done with our gem file, anytime we need to reference another gem like pry, require all inside of your project, we can kind of extract it out into a gem file rather than just putting it all on top of here. So what we end up doing is we create a separate gem file for it. And if you're creating from scratch, you're going to say bundle init. And if you type in bundle init, this is something that comes to us from the bundler gem. It will create a new gem file in the root of that project. So you do want it to be in the main root directory of your project here. And in here, we can write down all the gems that we're going to use. So we can say, oops, gem pry. That's it for now. And we don't really need this part. This is something that's automatically given to us, but we're not going to upload this to like a repo. But this part is important because we're saying go talk to rubygems.org to reference the code that I'm going to include inside of my project. So this is going to reference all of the public code that's available to us. And in order to take these gems and actually create a reference or a manifest file or a lock file for it, we need to say bundle install.
Okay.
And the bundle install will create a lock file for us. So this gemfile.lock is something that's automatically given to us. So it's telling, hey, I'm going to go talk to rubygems.org. I got all of these dependencies that I need. So even though I only included one gem, pry relies on CodeRay, method source, pry, and all of this stuff in order to run. So it'll also download all of its dependencies.
Okay.
Is there a way to make it when you run the bundle init to automatically just include like binding.pry or whatever other gems?
There might be. I'm not sure off the top of my head. I'd have to like look it up. For now, I think since you don't have any limit for the gems that you include or the type of gems, and sometimes you might include specific versions of gems, which you might have noticed in labs. That would be the reason that we just do bundle init and put all of this in here with the versions that we want.
Okay.
Yeah.
So how could you know which gems you need and which ones you do not need?
How could you know? Most of the time we'll give you the list of gems you need. But if you're like, I want to do this on my project, which you'll do for your mod 1 project, you'll like look up which gem is going to allow you to do that for you, and then you can just include it in here. So there will be times where you're like, I need 5 gems. So you include those 5 gems, and then you're like, oh wait, I missed 2. So you'll have to include 2 and then bundle install again so that you get the code updated for that.
Okay, thank you.
Mm-hmm. Yeah, like all of the gems you use will entirely be reliant on what you're doing in your project. I think I heard another question.
Oh yeah, I had a question. Going back to the add hikes.
Yeah.
So we have the add hike method, and then we also have the other method of adding a hike through like the mountain class. So for poo poo point, the hike.new for tiger, would we be able to randomize that as well?
Poo poo point.
Or line 16.
Yeah, so right now this one is not going to be random. And the reason, so what you mentioned is because we're doing this from hike.new, I think that's what you're saying. Like it's not going to be added to the hikes array, right? Potentially.
I think, or I was just saying, can we randomize the mountain that's added onto?
Oh, like create a sample hike for this.
Yeah, so then just do like mountain.all.sample for the tiger area.
Yeah. I can say poo poo point. X. Sure. And the reason also that this is more streamlined is because in my add hike, I'm also keeping track of my hikes array. And that's the only place that I'm adding my hikes that have been created. So through this, I have a way to automatically keep track of all of the hikes that are being created and automatically added to my array. Sweet. And I think Poo Poo Point is on Tiger Mountain, so I'll leave it like this.
Line 17 needs to have mountain added back in place of tiger. Unless you want, oh wait, no, we're keeping that there. Never mind.
All right, I'm gonna run Ruby sample.rb. Feel free to continue with questions. Yeah.
This might be what we haven't gotten into yet, but wouldn't this, like the way this setup, break single source of truth?
Mhm.
Because like if you don't call add hike, the mountain has no way of knowing. Even if a hike has Tiger Mountain set as its mountain, if you don't call add hike, Tiger Mountain has no idea. Like hike, yeah, like hike new tiger. If you just call hike.new Poo Poo Point,
Mhm.
comma tiger, tiger has no way of knowing that that hike belongs to itself if you don't call add hike.
Yep. That's why if you're not calling add hike and you're just saying hike.new, you'll need to have another method, maybe in your initialize, that is also talking to the mountain class to assign it to that array. So you can already kind of see like there's a couple extra steps that you need to do when you have that hikes array there. Yeah, good thing to bring up. Which we will talk about in a couple minutes. All right. Any other questions? Sweet. So as a review, what we've done so far is we have our mountain class, we have our hikes class. We said that a mountain has many hikes. So a mountain needs to be able to get access to all the hikes that belong to it, which we do with our hikes array. And a hike belongs to a mountain. So a hike is keeping track of the mountain object it belongs to. So now a hike can also say which mountain do I belong to and get access to that instance. And we created some kind of like sample code or some examples that we can use. We created some hikes and added it to the mountains array. And we're using add hike so that we can also add that hike to our hikes array, since that's the only location in our whole project that's happening. And this streamlines the process a little bit, so you're not creating hikes from two different ways. There's one way that we're using. So now let's see what this created. So we've made it to the end of our pry. And let's say mountain.all. And we got some code, which is good. And it's really hard to see, so I'm gonna like extend this all the way and open my annotate. Let me see if you don't see like the drawings that I will do. But let's kind of dive into this. We said mountain.all, and it's a mountain.all is an array, so we have this like start array here. How do I draw? Draw, and then color. Let me do like red. So we have this like array that starts over here and also ends all the way down here. Awesome. And we have three different mountain objects. So we have mountain object 1, mountain object 2, mountain object 3 with their proper distance, elevation, and hikes. Since we randomized it, we're seeing a good distribution of hikes here. And each mountain, because it has many hikes, has a couple different hikes instances. So this is awesome. We're seeing some data. Now what I want to point out is what's happening here. So we have a mountain instance, and our terminal kind of just gave up because it's like, ... What does this mean? What am I trying to do? And just gave up displaying this information. But if we kind of like unpack this, my mountain is this object right here. This whole mount thigh object, like circle it. This is my mountain. Oh my God, I can't draw. Oh, mount thigh. I'm trying to circle the whole mountain. And this whole thing is inside of this mountain object here for this hike. And when we unpack that, we have another mountain object that is a mountain that has the distance, elevation, a hikes array, which is an array that has another mountain object. So let me put like M, that has another mountain object. You probably see where I'm going with this, but mountain object with the distance, elevation, a hikes array. Sorry for my handwriting. And basically this goes on forever and forever and forever and forever. So while we have a way to keep track of the relations for a has many, when we store collections of objects, it can get super messy when you start adding more and more data. So right now we have like 10 different hikes. So it's not the end of the world if it loops on forever, because our computer will be able to handle it. But if this was happening with like 20, let's say this mountain has like 20 hikes, then each of that hikes mountain has a mountain object that has an array inside of it, which is like this hikes array. So I will pause there and answer any questions. Or if people are like,
So that's an infinite loop basically, because it would keep displaying a mountain object with a hikes array that has more hikes objects in it, where each of those hike objects has this mountain object that then has a hikes array that has more hikes objects that then has a mountain object inside. So does it know at some point to stop, or is that not an infinite loop?
it is an infinite loop.
Okay.
It'll stop when we run out of memory, which is great.
Wow.
So this is where it becomes inefficient when we're storing this type of data. Let me clear out the screen.
That's insane.
To kind of like illustrate. So we have this object, so I can say mountain. Oh wait, I need to, how do I do this? Mountain. So I can say mountain.all. And we saw kind of like a visual of what we represented. Probably should not have cleared it. But I can say mountain.all.first, and first will give me the first instance of that mountain. Cool, which is like this thing here. And I'm gonna clear it out so we can kind of see what's happening. Mountain.all.first. And I can also say first.hikes now, because I have that hikes reader. And then even in here, if we dive in depth, you can see like, got our two hikes object. Cool. And then because this is a mountain object, there's a hikes array. So I can weirdly say dot hikes, and then I'll have to say like hike of 0 because it's an array. Let's say I want to take a look at this, or 1, whichever
And
one.
you can call mountain again.
But I can say dot hikes again. Oh wait, I don't have hikes for that mountain. I gotta say hikes of 0, which is a hike object. I'm already losing track. Dot mountain. So I got my hike object. I can say dot mountain.
And then you could repeat that loop.
Hikes.
Right. And then it would just keep going. Oh my God.
I can do this infinitely forever and forever and forever and go in a loop because I have this in here. So this is insane. And
That's like some Phantom Tollbooth stuff.
that's like what?
It's like some Phantom Tollbooth stuff where you're like moving 1 grain of sand out of the pile into the
Yep.
well or whatever it was. I can't.
Yep, this is like the 1 grain of sand, and it loops forever and forever and forever. And this is just a demonstration to kind of illustrate moving forward why we will not be storing collections as objects inside of our array. So there should never be a point when you're designing your class where you have to say in a many, in like a has many belongs to relationship, for the has many, you should never be storing the collection of hikes. And this is just to like visually illustrate and in code illustrate how it can get super inefficient and messy, because now you have the potential of creating kind of like a loophole in your program. Like someone can come in here and be like, this is going to run forever. And
So we would never have that hikes as set to an array then, is what you're saying.
we'll never have that hike set to an array. It makes sense because you do want, it's a many relationship and you do want to keep track of those hikes, but you should not set it as an array.
Okay. All right.
So how do we keep track of it then?
Yeah, that's the next question. How the heck am I going to keep track of my hikes now? And we're going to let you like process this for a little bit. I want to give you a break because I always forget to like take a break. I'm sorry. Let's meet back at 11:30, and then I'll like leave you with this. Start thinking about how the heck am I going to get the hikes now if I'm not keeping track of it in a mountain, and mountain needs to know this information. So we'll take a break, stretch, get some water, and we'll meet back. The main reason that I want to introduce this kind of like rule convention now is when you're building out your database and your models, you're always going to have that thought in the back of your head, which I've seen where you're like, I can just store an array. And now we're going to say, don't do it. So if you're like, can I store a collection? You cannot. And just remind yourself of that. Also in the industry, when you're at Flatiron School, we work with SQL databases, SQLite databases, which is going to follow the similar convention here. You will at one point also hear about NoSQL databases, which doesn't really have any rules and you can do anything you want. That's like the only exception. If you're using a NoSQL database, maybe you can get away with storing collections, but for now, we won't be storing collections for the many in our model. Any thoughts, feelings, questions on that?
Could you repeat that, please?
Yeah, so in our, where we kind of left off before, is in our mountains model, we had this array called hikes. And because this is storing a hike object, this hikes is also keeping track of a mountain object, and it ends up being in an infinite loop. So when you're designing, when you're working with different models and defining relationships between them, the has many belongs to side, the belongs to will be keeping track of that one instance of a mountain, but the mountain will never be keeping track of a collection of all the hikes. So you should never have an array in there. Before they introduce this concept, there is a lab that makes you create an array. So if you're like, wait, Zandaria said I shouldn't do this. Why is this lab telling me to do this? That's the reason why. They're gonna show you like the long way or the improper, unconventional way to do it, to have you work with how painful it is, and then introduce like the more conventional or the easier way to implement it. So if you're working through that and you're like, this is frustrating, it's okay. You can move on to kind of the next labs after that. So if you see it, that is why. And another part that I wanted to kind of introduce why it's going to be more efficient to not store those collection is when you're representing a relationship between two models, there is this definition that like right now, when we had our hikes array, there's two different locations we're storing this relationship. We're saying hikes, mountains is keeping track of hikes because it's the many, and hikes is keeping track of mountain because it's the belongs to. And when we're talking about single source of truth, that might be a phrase you might have read through in the readmes. When we're talking about single source of truth, right now there's two sources to represent the relationship in our domain. And you never want to run into a case where there's two different sources for that. You want one source. You want one single source of truth in your project to represent that relationship. So if we take out this hikes array, let me like strike through it. I still want to be able to, as a mountain instance, find all the hikes that I want. So based on what we see here, what is the single source of truth to represent the relationship between a hike and a mountain? Any guesses?
It would only be in the
You can-
hikes.
I think I heard a couple responses. What was that?
Go ahead, Nathan.
Oh no, you would only be able to find that info within the hikes, right?
Yeah. So our single source of truth to represent the relationship between a hike and a mountain is the hike, because a hike belongs to the mountain. So when you're defining a belongs to and a has many belongs to relationship, the belongs to model holds the responsibility of keeping track of the instance it belongs to, and that's it. The has many model will never hold that responsibility. Another way you can think about this is, I've used like the country and citizens example before. Like if there's 1 million people living in a country, it's super hard to keep track of those million people instances, but it's very easy for that single person to say, like, I live in America, or I live in Japan, I live in Korea. That's just one data point that that person needs to keep track of, which is way much simpler than like, I'm gonna go through these million instances and find the person that I want. So now I can just ask the citizen and be like, hey, where do you live? And they'll be like, I live in America. So that's another way you can kind of look at it. And it'll also help when you're looking at like 5 to 10 instances. It might not seem like a big deal to keep track of that array, but when you're storing collections, imagine the case, what would happen if you had 1 million instances or 2 million instances, how difficult it's going to be to go through and search for that information. So when we say, like, what is the single source of truth for our project right now, our domain, it's going to be the Hike model. Pause for questions, thoughts.
And the Hike model is the single source of truth because I'm asking. Like,
okay.
Why is it?
Yes, the Hike model is a single source of truth because it is keeping track of the mountain object. This,
Okay.
like, through this instance being stored, it's saying, this is the mountain that I belong to. And I would have to go talk to the Hike class to get that information.
Okay.
Yep. And specifically, something I haven't like written here, like all of these we know are instance variables. And there's also the class variable add@all that's available in every single class that we write. So I'm gonna say add@all. Hike also has an add@all. So whenever I need to find information about my hikes, or the has many model has to find information about all the belongs to relationships, it's going to talk to this add@all array. So this is our connecting point, because our add@all, as we saw in our sample, I'll rename this from sample because sample is like inaccurate. But in hike.all, I'm keeping track of the mountain instance here. And my hike.all has every single hike that's possible. So this is going to be the most efficient way to look for that information. So I'm going to take out this hikes array. Let me move this here. And I'm also going to take out this because it's not just a getter anymore. If I wanted to rewrite my hikes, I'm going to say, wow, def hikes. So before it was a reader and instance method, so it's going to be the exact same thing, except now this array is not in here anymore. So I can like take this out too. And I'm going to take this out. Did I create it? Oh yeah, I took this out, took the reader out, and took it out of add hike. So I still need to be able to figure out a way to find all of the hikes that belong to me. And we kind of started formulating that we're going to talk to the hike class. So we're going to reference the hike class, and specifically the hike.all method, or or add@all array. And something I do want to point out, because hike does not belong in this class, it would need to access the hike.all reader. You can only access the add@all if you're in the hike class itself, but since you're in the mountain class, sorry, we can only access the reader for it. All right, so next task is how can I talk to, like, I need to go through add@all and find all of the hikes that belong to me. So let's go ahead and start. I'm gonna put a binding.pry. And are there any immediate thoughts on what we can do to sample? See if that broke.
Yeah. Do hikes.all.
Cool. So I can say hike.all.
.select. Oh, sorry.
So I got all the hikes, and this is perfect because hike just has a mountain. That's just one instance now, which is great. So I can say hike.all, and it was select.
And then open a code block. like just curly bracket.
Brackets,
And then for the parameter, pass in hike,
hike.
which will pull the hike object. And then do hike.mountain
Ooh.
equals self, which at the time this is being called would be the instance of the mountain class that you're calling it on.
Thank you. So we got an option that we can use to find all of the hikes. And let's like go through this. Thank you. So we'll see what this does. Something I like to do whenever you're working with enumerables, I'm not sure if this will go through, I'm gonna expand this, I'll say do like, is put a binding.pry in between so we can kind of debug it. I'll move this here down. And we can take a look at what hike is, what mountain is, and what self is. And this is another great place. Whenever you need access to that instance, you can reference self. So let's see what this does. Let's also double check and see if this will return what we want. So we're in the same method as before, except now I'm inside of my binding.pry for my hike. And let me click out of this and move this to the side in case it's like hard to see on the side here. All right. So I'm in my loop. If I type in hike, I get access to that first hike that I'm looking at in my add-all array. And select is another enumerable, and you'll get more practice in the enumerables review this afternoon. But this is a great opportunity to start looking at enumerables and how you can use these on our add-all array, because the add-all array for our objects is something that you'll be doing continuously throughout the next couple days and next week. So get comfortable with enumerables, get comfortable with saying like hike.all, model.all, and seeing what conditionals you need to pass in. So select is gonna go through every single hike in the hike.all, and it takes in a true or false value expression. And if it's true, it's gonna return it in a new array. It's gonna add it to the new array, it'll return. If it's false, it's gonna ignore it. And the ones that I care about right now is the hikes that belong to this specific mountain, because that's what we were keeping track of before. If I type in self, this is Mount Si. Mount Si only cares about all the hikes that belong to Mount Si, and that's it. And then the only match point between this hike object and this mountain object is this object ID here. Well, I don't think the object ID.
So you're comparing the object IDs from both of them?
Where's the mountain? Oh, mountain. No. Oh yeah, right now it's not Mount Si, so this is gonna skip it. What was that?
So you're comparing not really names, but the object IDs.
Mm-hmm.
Okay.
Yep. The object IDs are going to be the most efficient way to do these comparisons, because if you think of a person, there could be a person with the exact same name, but they're two different people.
Yeah, for like this case, you could do like hike.mountain.name and then equal to self.name, and then that would still equal the same thing, right?
It will, if you know that your data set is unique. I would say, yeah, it'll still work if you compare the name. It's still going to be more secure to be sure that you're going to get that exact same object if you compare the whole object.
Sweet. Okay.
Yeah, that was a good question. So in this case, we can see like for Tiger Mountain, it's not going to match up. So it's going to return false, and it'll ignore this specific hike, and then it'll just continue after every single iteration. I'm going to clear this out. And then now if I type in self, Mount Si, if I type in, well, self is, Mount Si is always self. But somewhere in here, there is a hike that belongs to Mount Si through all of our examples. Let me, if I hit 2 exclamation points, no. I'm going to take out my pry. So that's what the hike.mountain and self is doing inside of this enumerable. Now if I do Ruby sample.rb, I can say sci.hikes. That enumerable went through all of the hikes array. So it did hike.all, and it selected only the hikes that I care about, where hike.mountain equals self. And what we got is this new array with 3 different hike objects that have that matching mountain instance.
And the self matches whatever mountain name you're passing it, right?
Yep, exactly. So if I do tiger.hikes, self changed. Self in this case was Tiger Mountain, so you get a different list of hikes.
Because it's inside the hike method.
Because it's inside the
That's
the
why.
hike method for that mountain. Yes.
Yeah.
Yep.
For a different syntax for the instead of select, could you just do .include?
You could do .include. I'd have to double check what it returns. Yeah, you'll notice like Ruby has aliases for different enumerables that do the exact same thing. So you can do select, you can do find all, you can do filter. If include takes the object ID, and I'll have to double check, and it returns an array, then you can do includes too. Yeah. The main part is you're matching up the instance with itself.
Yeah,
So
it basically
the-
returns a true and false.
Okay, so if it returns true or false, you can use that maybe inside of the self, because it just needs that true false value, and that'll be able to match up.
Okay. I was just thinking about how to shorten that 2 lines to 1 line.
Yeah, and I know initially it was like the curly brace. Sometimes pry doesn't go through the curly brace, which is why I added in there. But it'll also work if you have just like the 1-liner. It's the shortcut.
Yeah.
Sweet.
So the point is the comparison and not the enumerator really, because it can be any enumerator that can work.
It can be any enumerator. You just want to make sure that the final result that's returned to you is the hikes that belong to this mountain. That's what we're looking for. So if you pick a different enumerator, that's okay. Different enumerators take in different conditionals inside of the block. So that's what you have to pay attention to. But yeah, so it'll, but you can use any of them.
Yeah.
I don't really have a preference, or for me, I'm like, as long as you're comfortable with what you choose and decide, that's the main part. You exit out of this.
In the code block, in between the pipes, you have hike. And that, yep, there is actually referring to on the right side, the actual hike ID.
This is referring to the whole hike object, which technically is going to be looking at the hike ID. Like it'll look at this object ID to do the match.
Yeah, okay. Huh, okay.
Like
that's why the name doesn't actually make a difference. You could call hike blah, right, or Z or whatever, because it just knows to look for that object or the
yeah.
Okay.
That's just a placeholder.
Yeah. Okay.
It was like the bikes discussion earlier.
Ooh. All right. So we kind of got to see a representation of how to implement a has many and belongs to inside of our class for mountains and a hike. And the main lesson is when you're storing that relationship, even though a mountain has the possibility to have many hikes, we're not going to store that relationship in the mountain class. We are going to talk to the hike class who has the responsibility of keeping track of the one mountain instance it belongs to. And to kind of give you practice with that, I do have, I know we have 10 minutes remaining. Feel free to work on this later also. Where's my domain? Oh wait, I think it's in here. So similar to a mountain and a hike, I have a new model that we can work with, and you can keep hike exactly the same. So you can use the hike. I'll push up this code. You don't have to like make any changes to hike because it has, well, you will have to at some point. But let's build a new model or a new domain. And now you're the person. So we said there is a mountain and a mountain can have many hikes, but now there is a customer, not a customer, quite a customer, a person. So we are the person, we are the people. And a person can go on many hikes. And let's say for now, what did I pull up? Go away. Can I like move? I don't know what I actually clicked on. Let's say for now, a person can go on many hikes, but that specific hike belongs to a person, which is why you see this customer here, because we can go into like super in-depth rabbit hole conversations that this can be like a many-to-many, which we'll explore tomorrow. But for now, that single hike, that person, that one person can do at that time. So a hike belongs to a person. That's our relationship. And let me like copy paste this. Person can go on many hikes. Whoa, what happened there? No. No, that's not what I wanted. All right.
And kind of like what you mentioned earlier, like there's no reason for the hike to know all the people that went on it, I guess.
Yes.
Right.
So what you'll notice here is, let's say 5 different people go on a hike. Then there will be 5 different instances of that hike, but the customers will be different.
Yeah. Oh, great.
This is like the really random odd case where you can have multiple hikes that will have one instance of that customer person. So this is what we're gonna build out. Or this is like homework for you. Build out the person class, build out the hike class. Person has many, can go on many hikes, person has many hikes. Hike belongs to a person. I'll upload the mountain code, I'll upload the hike code that we worked on, so you can definitely use that as a guide to build this out, and Slack me the code that you have at some point by end of day today.
End of the day today or tomorrow?
End of the day today. I will be looking at it realistically tomorrow. So if you're like, I can't get this done by tomorrow, and we'll implement this in class tomorrow. So if you're like, you want to work on it, but you couldn't finish it, we'll implement it together in our many-to-many lecture. So I just want to see you try implementing it first, and then we'll incorporate it into the program.
And then today meeting 6 p.m.
Ooh, that's always a good question. I would like 6 p.m., but I know you're also going to be working on labs and reviewing. So I could do, like, I could do it the tech way and say end of day by, no, that's not healthy. Never mind. Sometime by end of day today. I'll say after school is okay. Just don't stay up working on it too late.
And you want us to do, can you repeat exactly what you, like the desired outcome is that you want?
Yeah, so our model right now, we're defining a new model relationship, which is person and hike. And in here, I'm going to, similar to what we did with hike in here and what we did with mountain in here, we are going to write 2 new classes for a hike and a person. And you technically like don't have to write 2 different classes. Like you can use the hike here, that's fine. Make some modifications to it. So you don't have to rewrite this. But I would like to see that relationship in code.
So what you want is to update hike so that it can belong to a person, and then to create a person class so that it can have many hikes. And we would just access it with like person.hikes to see all the hikes that belong to that instance of the person.
Yes.
Okay, cool.
And I will also include that in, like I can send it as a Slack message so that you can use that as a reference too.
Thanks.
Yeah.
Thank you.
Sweet.
Yesterday you said that you made a YouTube channel where you're putting all these videos. so that we can rewatch them?
I'm gonna stop share real quick, and then I'll open up the Slack because I'm gonna switch screens. All right. Yes, let me reshare. I think my Slack is up. And if you go to the pinned stuff here, I have the class repository pinned and I have this playlist pinned. So as soon as this video is done processing, you'll be able to see it all in here. So I try to add it. I also try to access like Ahmed's lessons that he does and add it on here as soon as I get the link. So we'll try to do that. I think he owns his own videos, so he might have to add it. But the ones we go through will get added typically like a couple hours after lunch or by end of day.
Okay.
And if you want to like pin anything else to your source here, feel free to do that. All right. Go back to code. And then we go back to
just to clarify for the little assignment, the person is the has many and the hike belong to the person?
Yes.
Okay.
Let me go NBC Rails. Yep, person is the has many and hikes belong.
Okay.
I'll also take a screenshot of this and I'll post it. This app is great when it's working and then it's just like freezes sometimes. Why? All right, let me stop sharing. Any other final questions? I know that kind of like getting introduced to models talking with each other can feel a little weird in the beginning. So if it's not all like 100% clicking right now, it's okay. You'll be able to see more examples of this and we'll review the person hike class tomorrow and build it out. And also this will get reinforced once we introduce like the many-to-many has many through relationship tomorrow. So you'll get more samples and practices with this. So don't feel like it has to be like 100% right now. It's okay.
Which of the READMEs and labs right now that are available would you recommend us to go over?
Let's see. So I think I linked, go back to Slack. The has many objects through and the has many objects through lab. That's the one that's going to go over the many-to-many for yesterday. Okay. And then at the end of the day, I think I linked the has many through README. If you need to review the has many and belongs to, it would be the has many and belongs to README for that. And that'll walk through everything we did in our lesson today.
Okay, thank you.
Yeah. All right. Thank you all. I will end a couple minutes early today. Go have some food. And I don't think we have anything happening right after our, right after lunch. It's going to be lab work time.
It says on the thing that it's enumerables on the Slack
enumerables
channel.
will be at 2. Yeah.
Oh, it'll be at 2, but on Slack it says 1 to 2.
Oh, does it?
Mm-hmm.
Oh, because yes, that makes sense. Ahmed is 1 hour ahead because he's in Denver.
Oh.
So I will let him know and double check.
Okay.
So if it is at 1, I will update you all right away. Yeah, it like totally makes sense. When I was helping out in Denver, I mixed up the hour differences all the time. So I'll double check with them to see if it's 1 p.m. Pacific, and if it is, we'll update it on the schedule.
Thank you.
Yeah, thanks for letting me know. Yes. All right.